Okay, so we've been talking about chemical equations, the law of conservation, and now we're going to talk about signs of chemical reactions. So here are some examples. And a good rule of thumb when you're trying to determine if something has gone through a physical change or if something has gone through a chemical change is, has something new been created or destroyed? Ask yourself, has something new been created or destroyed? If we have made something new, then it is a chemical change. Okay? But if the substance, the chemical formula of the substance didn't actually change, then it's just physical. Okay? So here are some examples of physical changes. Aluminum foil being cut in half, still aluminum foil. Clay being molded into a new shape, still clay, just looks different. Butter melting. It's still butter, but it's a liquid now. It went from a solid to a liquid. That's a phase change. Evaporate. Evaporation is a phase, it's a process of how we change phases. So this is physical. Water evaporates from the surface. Juice box freezing. That's going from a liquid to a solid. That's phase. Rubbing alcohol evaporates. Okay? That is a process of a phase change. This is going from a liquid to a gas. Okay? So those are your physical change examples. Some other examples are things dissolving. That's physical. And then things like density. When you have something that asks you about the density, that's physical. Okay? Your chemical changes, milk going sour. Anything that is rotting or decaying or going bad is chemical. It's basically breaking down and decomposing. Jewelry tarnish. Okay? Tarnish is another word for rusting. It just depends on the type of metal. But when jewelry tarnishes, it's undergoing oxidation, which is a chemical reaction. Okay? When bread becomes toast, we're burning it, we're applying heat, and we're changing the chemical composition of some of parts of the bread. Okay? So this is chemical. Again, rust forming on a nail. This is called oxidation. This nail is creating a new substance when it rusts. Okay, the rust is the new substance. When we light gasoline on fire, okay, when we light anything on fire, it's called combustion, and that's a chemical change. When hydrogen peroxide bubbles in a cut, bubbles is a sign of a chemical change. The hydrogen peroxide is reacting with the germs and stuff inside your cut. Food scraps turn into compost. That's basically saying that the food scraps are decomposing. We lit a match on fire and an acid to settle your stomach. Digestion is a chemical process. And then frying an egg. Okay, we're cooking it. When you cook something, not when you melt something, but when you cook it, like bread and toast, baking a cake, those are going to be chemical. Okay, so a chemical change is the formation of a new substance. That is the key. Formation of a new substance. New substance is created. When you have something brand new after a reaction, it is chemical. Okay, it's going to have different properties. Chemical reactions are accompanied by a chemical change. The elements in the reaction, if we look at our equations, let's look at this equation. We have hydrogen and we have oxygen. They have different properties here, but when we combine them in a reaction, we make water. So we have the same number of atoms on both sides, but the substance itself, the hydrogen and oxygen, when they're chemically bonded together, they change. Just like sodium and chlorine being really unstable alone, but once we combine them, they make salt, and salt has completely different properties than sodium does alone or chlorine does alone. Okay? Physical change, it doesn't change what the substance is. doesn't change it. Okay, and we went over some examples. It says whipping egg whites, no new substance. H2O transforming from a solid to a liquid state, or any other kind of phase change, like boiling water, where water is turned into a gas. We are still going to chemically represent ice, water vapor, or liquid water as H2O, no matter what phase it's in. So here are some more examples of chemical changes. You're always going to have a new substance. So when iron rusts, it's iron combining with oxygen to form iron oxide. Excuse me. Which is rust. Okay, we call rust chemically iron oxide. It's a brand new substance. When gas burns, it's going to create water and carbon dioxide. Okay, so gas is something different than water and carbon dioxide. So it's creating new substances. When eggs cook, that is a chemical change. Bread rising, yeast converts to carbohydrates into carbon dioxide gas. You guys explored yeast in 7th grade, I believe. Here is the acronym that you guys were exposed to in 6th grade. I don't know if you remember it. Please excuse burps, coughs, sneezes. Okay? And the first letter of each one of these words stands for an important vocabulary word. And then we have a bunch of picture examples here. The first one is a precipitate. Does anybody remember what a precipitate is? When you mix two liquids and they form a solid, like milk and vinegar or milk and Red Bull, when you mix them, and then it's going to form a solid. That's not a phase change exactly. You're mixing two liquids and then a solid was created. So we're creating a new substance. So a precipitate is an example, is a sign that a chemical reaction has occurred. So in a little at-home experiment, you get a cup of milk and you get a cup of Red Bull or a cup of vinegar, and you mix them together and let it sit. Your milk's going to get chunky. Kind of gross, but it's cool at the same time. Okay? The E, we say excuse, stands for an energy change. Okay? And there's 3 types of energy that we focus on. We focus on exothermic, endothermic, and then light. So heat energy or thermal energy and light energy. Exothermic, exo, like exit, heat is given off. So in a reaction, it's going to feel warmer to you. It's going to start off not feeling like anything, like room temperature. And then as the reaction proceeds, the glass, the beaker, the flask, whatever you're using is going to get hot. And you're not applying heat to it. You're not applying heat to it. It's not like it's on a hot plate or coming out of the microwave. You mixed 2 substances, and as they react, the glass gets warmer. Okay, heat's given off from the reaction. So exothermic, it gets hotter. Okay. Endothermic is the opposite. The reaction is using up all the heat. So in an endothermic reaction, you mix 2 substances and they become cooler. So you can feel the flask or the beaker, whatever you're using, you can feel it become colder. Okay, so it goes from room temperature to cold in your hand without any other type of action by you. It's just the reaction that's using up all of the heat. And then the production of light. So we have glow sticks as an example here, but fireworks are also a really amazing example of energy change in chemical reactions. Okay, when light is something is created and light happens as a result, that's a sign of a new substance being created. Okay. The next one is burps, which is really appropriate when you think about what burps are. When you burp, it's literally a gas bubble from inside your body leaving your body. Okay, so bubbles is when a gas is formed. Like when you mix baking soda and vinegar, it bubbles, and that it's releasing a gas, okay? Coughs, the key word for this is unexpected. When you add food coloring to water, you expect that color change. That's not a chemical change. Food coloring into water is physical. You add red food coloring to clear water, what do you expect is going to happen? The water is going to turn red. But if you look at this image, when you add two clear liquids and you get a bright yellow, that's wild. That you don't expect that to happen. This is a sign of a chemical change. Okay? And then the last one is sneezes, which is a smell produced. So vinegar has a strong odor to start with. So if you smell vinegar at the end of a reaction in an experiment where you used vinegar, that's not a sign. But if a whole brand new odor comes out and you're like, whoa, like smoke. Smoke is a brand new odor. You didn't smell smoke before the fire, but after the fire you can smell smoke. That's a good sign of a chemical reaction. You think about how fireworks smell after you light them. That is a sign of a chemical reaction. The fireworks don't really smell before you set them off, but after you set them off, you can smell it. So this is just, again, reviewing each word that I just went through for you, each vocabulary word. The P stands for precipitate, and it's when two liquids make a solid. Okay, that's the key. Two liquids make a solid, and you can see that right here. They added two liquids, and this yellow stuff is going to solidify. I actually did this in high school. It was really cool. And then over here, this is, you see it looks real thick and chunky. It's going to solidify. Excuse for an energy change. Light will be produced. And then you have two types of thermal energy change. Endothermic, which is cold. Energy is absorbed and the temperature decrease. Exothermic is hot and energy is being released, so the temperature will increase. Okay? So endo, enter, absorb. Exo, exit, release. That's how I like to think about it. This is the science behind glow sticks. So I think it's really interesting because a lot of you guys think that glow sticks have the element neon in them, and they don't. Neon is not in glow sticks at all. So this says the science behind glow sticks. How do they produce light? But I think that it's cool that this is a whole chemical reaction in a little plastic tube, and it releases light. It glows for a little while until all that energy, excess energy, is gone. And there's no neon. They just have a cool color. So we got burps for bubbles. Think about your burps. It's a giant gas bubble. Okay? You can see these bubbles. It's a sign that a gas has been produced. Coughs, unexpected color change. So we have yellow and we have clear, and when they were mixed, it made red. That's unexpected. If we mixed yellow and blue and got green, that's expected. Yellow and blue mixed together make green. But yellow and clear making red, not expected. That's different and surprising. Here we have, I don't know if that's a solid, like a piece of metal wiring, but they're mixing this metal with this clear substance and a blue solution is formed. And that's unexpected. You wouldn't have thought mixing these two substances would make this. Okay? So it's got to be unexpected. That's why food coloring is not a chemical change, because it's going to change that color. Sneezes stands for smell. Okay? And when we smell things, we waft, but it's going to be a brand new odor.